Have you ever wondered how an electric motor works? Electric motors are everywhere, powering our cars, appliances, and even our toys. These marvels of modern technology convert electrical energy into mechanical energy, making our lives easier and more efficient. By the end of this exploration, you'll grasp the fundamental principles behind these powerful machines. So, buckle up and prepare for a fascinating journey into the heart of electric motors. Dive with us into the exciting world of electric motors and learn how they turn electrical energy into mechanical energy. Before we delve into the workings of an electric motor, we must first understand the fundamental concept of electromagnetism. Electromagnetism is the interplay of electricity and magnetism, the two halves of the same coin, if you will. The magic begins when an electric current flows through a wire. This current creates a magnetic field around the wire, turning it into a simple electromagnet. It's like giving the wire a magnetic aura, which can attract or repel other magnets. Now let's up the game a bit. If we coil this wire around a metallic core, the magnetic field intensifies, creating a stronger electromagnet. It's like adding fuel to a fire, making it burn brighter and hotter. Here's where things get interesting. When this magnetic field interacts with another magnetic field, it can induce movement. This is the heart of electromagnetism and the spark that ignites the workings of an electric motor. With the foundation of electromagnetism clear, we can now move on to how this principle is applied in an electric motor. Now let's dissect an electric motor and familiarize ourselves with its key components. At the heart of an electric motor, we find four main components. First up is the stator, often referred to as the stationary part of the motor. This component typically houses the motor's windings and is responsible for creating a magnetic field. Next, we have the rotor, the moving part of the motor. It's positioned within the stator's magnetic field, and when it's exposed to electricity, it spins, creating the mechanical energy we harness. Then we have the commutator. This component may seem small, but it plays a significant role. It switches the direction of the current flowing through the rotor, maintaining the rotor's spin in the correct direction. Lastly, we have the brushes. These pieces of graphite or metal maintain an electrical connection with the rotating commutator, ensuring the motor keeps running smoothly. Understanding these components is crucial to grasp how an electric motor operates. Now that we know the components, we can finally unravel the mystery of how an electric motor works. Picture a simple loop of wire, our rotor, placed within the magnetic field of a permanent magnet, our stator. When current is passed through the rotor, it too becomes a magnet, and as we know, like poles repel and opposite poles attract. This pushes the rotor to spin, trying to align its poles with those of the stator. However, just when alignment is about to happen, a clever device called a commutator flips the direction of the current, reversing the poles of the rotor. This keeps the rotor spinning because now, once again, the rotor's poles are trying to align themselves with those of the stator. This cycle repeats, keeping the rotor in constant motion. The spinning rotor is connected to a shaft, so when the rotor spins, the shaft spins too, generating mechanical energy. This mechanical energy can then be used to power anything from a small fan to an electric vehicle. There's more to it, of course, with complex motors using multiple loops of wire and precisely timed current changes. But the basic principle remains the same. An electric motor uses the interactions of magnetic fields to convert electrical energy into mechanical motion. So that's how an electric motor transforms electrical energy into mechanical energy. Let's recap what we've learned about the workings of an electric motor. It all begins with a fundamental concept, electromagnetism, which is the interaction of electric currents or fields and magnetic fields. This principle is the heartbeat of an electric motor. Next, we delved into the key components of an electric motor. We discussed the stator, the rotor, and the commutator, each playing a crucial role in the operation of the motor. The stator generates a magnetic field, the rotor rotates in response, and the commutator alters the direction of current to maintain rotation. We then walked through the step-by-step operation of an electric motor, illustrating how these components work in harmony to convert electrical energy into mechanical energy. The interplay between the magnetic fields and the electrical current results in the rotor's continuous rotation, driving the motor's mechanical output. The next time you use an electric appliance, remember the fascinating process that makes it work. Thanks for tuning in and keep exploring.